Assalamu alaikum AS Physics students, welcome to the secret sauce video of AS Physics. What will happen in this video? Let me tell you. First of all, we will be discussing the definitions. This document is attached in the description, you don't need to worry about it. We will be discussing the definitions of AS Physics, the graphs that come in AS Physics, all the formulas of AS Physics, and lastly, I have written some examination tips. Some examination tips from the last 20 years. So let's start with this video. We will be going over definitions, graphs, formulas, examination tips. Definitions and formulas I have gone through in the speedrun video as well. Primary focus will be on graphs and how to solve them. Okay. So let's come on to the first chapter, that is physical quantities and units. Okay. So you have some definition of physical quantities and units. There are 7 base quantities and derived quantities are infinite. You need to know what is homogeneity of an equation. The base units on the left hand side should be equal to the base units on the right hand side. That means your equation is said to be homogeneous. Then you must know or memorize these prefixes of 10. Tera is capital T, 10 is the power of 12, and all these prefixes should be memorized by you. Then you must know systematic errors are errors of constant signs. That means they can either understate all the values or overstate all the values. Systematic errors are represented by a non-zero y-intercept. Simple. Now let's come on to random errors. Random errors are of varying signs and random errors result in a scatter plot. Random error result in a scatter plot. You can take average to reduce random error. Simple. Precision is how close the measured values are to each other. Accuracy is how close the measured value to the actual value. Here I have given the graphs of precision and accuracy as well. I have discussed this in the speedrun video, so I will not be focusing on that too much. The speedrun video is also attached in the description. Now, you must remember that absolute uncertainties will always be given till one significant figure. Percentage uncertainties, on the other hand, will be given till two significant figures or 3 significant figures. These are some scalar and vector quantities that you need to remember. And the most important thing, I have attached a table of estimations that you need to remember. I have attached a table of estimations that you need to remember. You need to memorize this by heart, all these estimations. Okay. Now, some examination tips to remember. Whenever you are multiplying or dividing, fractional uncertainties will add up. Whenever you are adding or subtracting, absolute uncertainties will add up. Whenever you have to calculate the maximum resultant vector, you will make both the vectors connected at 0 degree. So whenever you have to calculate the maximum resultant vector, both the vectors will be connected at 0 degrees. However, when you have to calculate the minimum resultant vector, both the vectors will be connected at 180 degrees. Perfect. When both the vectors are connected at 90 degrees, you will use Pythagoras theorem and trigonometric ratios. This is everything that I have discussed in a speedrun video as well. Now, kinematics, you have some definitions initially. These are some definition of kinematics that you have. Then you have some formulas for kinematics as usual. Some formulas for projectile motion as well. Formulas for half projectile motion as well. Now let's move on to the graphs of kinematics. First of all, you need to remember that if the gradient of a line is 0, it will be a horizontal line. If the gradient of a line is positive and constant, it will be an upward sloping line. If the gradient of the line is negative and constant, it will be a downward sloping line. If the gradient of the line is increasing, you will have an increasing curve like this. Perfect. However, if the gradient of the line is decreasing, you will have a decreasing curve like this. Simple. Now let's apply these. Before applying these things of gradient, before applying these gradient key types, you need to know some more things as well. You need to know that if your graph is of y is directly proportional to x, it will be a straight line passing through the origin. If your graph is of y is directly proportional to x, but you have a positive y-intercept, you will have a graph like this passing not through the origin. This graph will not pass through the origin because it has a positive y-intercept, and y is directly proportional to x. That's why it is a straight line. If you have to draw a graph of y is directly proportional to x square, you will draw a curve like this. Simple. If you have to draw a graph of y is directly proportional to under root x, you will draw a curve like this, decreasing curve like this. Perfect. Now let's apply these formulas. Also, throughout this document, I have included all the various types of graph questions that can come in your examination. So please pay attention, please look closely. Let's solve this. The child in B travels down a slope at a constant angle to the horizontal as shown in figure 2.1. Okay. At A, her speed is this. She has a constant acceleration of 0.85 ms minus 2 parallel to the slope. After a time of 3.7 seconds, she reaches point B. Okay. So at A, she has a speed of 0.6 ms minus 1. At B, she reaches after 3.7 seconds and has an acceleration of 0.85. Okay. Okay, we don't need to calculate the distance right now. I am only concerned with the graph. Okay. So from A to B, I want to bring to your attention that we are accelerating with the acceleration of what? 0.85 ms minus 2. This acceleration is both positive and constant. Please remember this. This will come in handy once we plot the graph. At point B, the child in C applies the brake with a constant force to maintain a constant velocity. Okay. From B to C, you have a constant velocity. Okay. Constant velocity. Perfect. Now, on figure 2.3, sketch the variation of kinetic energy of the child and the scooter with the distance traveled from A to C. Numerical values for kinetic energy are not required. You have to plot a graph of kinetic energy versus distance traveled. How will you do that? Okay. Sit back, relax, you don't need to panic. First of all, can you realize kinetic energy is equals to what? 1 upon 2 mv square. Now you don't have to plot a graph of kinetic energy versus velocity. You have to plot a graph of kinetic energy versus distance. What will you do? You will say velocity final square is equals to the initial velocity square plus 2as. Okay. So you can say from A to B, since you are accelerating with a constant value, you can apply this equation of motion. V square is equals to u square plus 2as. Okay. So instead of this v square, you will place what? Kinetic energy is equals to 1 upon 2m u square plus 2as. Okay. Can you rearrange this? Yep. Kinetic energy is equals to 1 upon 2m u square plus 2 to cancel out. This will become mas. Okay. Now I want you guys to realize something. This is not that easy. Okay. Kinetic energy is equals to mas plus 1 upon 2 mu square. Can you realize kinetic energy is being plotted on the y-axis? What is being plotted on the x-axis? Distance x. This is your gradient. This is your y-intercept. So basically you will be starting with a positive y-intercept and you will have a straight line like this. Then for the part from B to C, can you see you have a constant velocity? If your velocity is constant, your kinetic energy graph will also be constant like this. Simple. This is the graph, how you have to draw it. Remember this always. First of all, calculate the relationship between the two variables or identify the relationship between the two variables. Then you draw the graph. Okay. Now let's discuss distance time graphs and speed time graphs as well. There are three key points that you need to remember. The gradient of distance time graph is speed, the gradient of a speed time graph is acceleration, and the area under the speed time graph is distance. These are the three key points that you need to remember. If you are traveling at uniform speed or constant speed, your speed time graph will be a horizontal line or constant. How will you draw the displacement time graph or distance time graph? You know that the gradient of distance time graph is equals to velocity. If velocity is positive and constant, that means gradient is also positive and constant. If your gradient is positive and constant, you draw an upward sloping line like this. Simple. Let's move on to the next scenario. Uniform acceleration. Always remember, uniform word means constant in AS physics. Whenever you see the word of uniform, that means constant for AS physics. Okay. Now, let's say you have uniform acceleration, your acceleration is constant. What is the gradient of velocity time graph? Gradient of velocity time graph is acceleration. If acceleration is positive and constant, your gradient is positive and constant, your velocity time graph will be an upward sloping line. Perfect. That's why knowing the types of gradient is so important. That's why knowing the types of gradient is so important. If your gradient is positive and constant, upward sloping line. If your gradient is negative and constant, downward sloping line. If your gradient is a gradient is increasing, you draw an increasing curve. If your gradient is decreasing, you draw a decreasing curve. If your gradient is zero, you draw a horizontal line. Simple. Here, in the uniform acceleration case, your gradient is positive and constant, you draw an upward sloping line. Okay. Now for the displacement time graph or the distance time graph, can you realize the gradient of this graph is equals to velocity? And since velocity is increasing, your gradient will also be increasing. If your gradient is increasing, you draw an increasing curve like this. Simple. Now let's see what happens when you have increasing acceleration. Increasing acceleration means that the gradient of velocity time graph is acceleration. That means acceleration is increasing. Gradient will also be increasing. So you draw an increasing curve like this. Okay. If your velocity is increasing, what is the gradient of displacement time graph? Gradient of displacement time graph or distance time graph is equals to velocity. If velocity is increasing, the gradient of distance time graph will be increasing. This will also be an increasing curve. Simple. Let's move on to decreasing curves. Or sorry, decreasing acceleration, my bad. This is your next case, that is decreasing acceleration. We know that the gradient of velocity time graph is equals to acceleration. If acceleration is decreasing, the gradient of velocity time graph will be decreasing. You will draw a decreasing curve like this. Simple. Always remember, gradient is decreasing, you draw a decreasing curve. Gradient is increasing, you draw an increasing curve. Simple. Now, although the gradient of the graph is decreasing, you draw a decreasing curve here. But can you realize that the velocity is increasing? The velocity is still increasing. And the gradient of distance time graph is equals to velocity. If velocity is increasing, that means the gradient of distance time graph is increasing. This will still be an increasing curve. Now let's move on to deceleration. Deceleration means what? Negative acceleration. Okay. If you have negative acceleration, that means what? Gradient of velocity time graph is what? Gradient of velocity time graph is negative and constant. If your gradient is negative and constant, as you have seen from the types of gradient, we will draw a downward sloping line. Now here your velocity is decreasing. Your velocity is decreasing, so you will draw a decreasing curve for the displacement time graph or the distance time graph like this. Simple. Let's further move ahead with the displacement time graphs and the velocity time graphs. You have to remember that the gradient of displacement time graph is velocity and the gradient of velocity time graph is acceleration. Area under the velocity time graph is displacement. Three key points that you need to remember: gradient of displacement time graph velocity, gradient of velocity time graph acceleration, area under velocity time graph is acceleration. Oh, area under velocity time graph is displacement, my bad. Okay, so these are the three key points that you need to remember for displacement time graphs and velocity time graphs. Let's say you have a ball like this, okay, and since these are vector quantities, I have also written a key point. Whenever your question has vector quantities, the first thing that you will do is to mark the axes. Upward as positive, downward as negative. This is the convention that I like to take. Okay, so you have taken the upward vector as positive, downward vector as negative. Initial velocity is of u pointing upward. This will be positive u. Always remember, the vertical velocity at maximum height becomes 0. Okay, so you start from a velocity of positive u. At the maximum height, your velocity is 0, and once your ball touches the ground again, you will have a downward velocity of u again. Since downward vectors are negative, this velocity is negative u. Perfect. So you have 3 points here, you connect them, you draw this line. Perfect. Now we know two things about velocity time graph. You need to pay attention here if you want to be successful at AS Physics. There are two things that we know about velocity time graphs. The gradient of velocity time graph is acceleration. Okay, can you realize that there is no air resistance here? That means acceleration will be 9.81 ms minus 2 acting downward. And since downward vectors are negative, your acceleration will become negative 9.81 ms minus 2. Since downward vectors are negative, acceleration will become negative 9.81 ms minus 2. So that means your gradient of velocity time graph should be constant and negative. Why? Because your acceleration is negative 9.81 throughout, it is constant and negative. And you can see that a downward sloping line represents a negative gradient and it also represents a constant gradient. So yeah, that is being proved. You need to remember that the velocity time graph gradient is equals to acceleration. Okay. Here you know that since there is no air resistance, acceleration will be acting downward. If acceleration is acting downward, it has a value of negative 9.81 ms minus 2. If the gradient is negative 9.81 ms minus 2 or negative constant, that means what? Your line will be a downward sloping line like this, simple. Why? Because the gradient of the velocity time graph is acceleration. Okay, the second thing that you need to know here is that the area under velocity time graph is equal to displacement. Perfect. So when the ball is rising up, what is the displacement or the height covered? That is this h, or you can say that is this is a. This is a. When the ball is rising up, this is the area A or the height A that is covered. Okay. When the ball is falling down, like this, the area covered or the height covered is B. So yeah, so let's label this as B. Simple. The area under the velocity time graph is displacement. The gradient of velocity time graph is acceleration, and the gradient of displacement time graph is velocity. Some key points that you need to remember. Then you have the displacement time graph. Initially the displacement is increasing as it is moving upward in the positive direction. Then as it moves downwards, the displacement decreases and comes back to its original position. Perfect. Then you have the acceleration time graph. Since the acceleration is acting downward, then downward vectors are considered to be negative. You have an acceleration of negative 9.81 ms minus 2. Now you also need to know the graphs of terminal velocity. Okay, so terminal velocity ke liye you need to know the velocity time graphs as well, displacement time graphs as well. Whenever you have to draw the velocity time graph of terminal velocity, you will break it down into two portions, this yellow portion and the blue portion. Perfect. This yellow portion and then this blue portion. Perfect. What does this yellow portion represent? This represents that the gradient is decreasing. That means acceleration is decreasing. What does this blue portion represent? This means that the gradient is 0, acceleration is 0. Why? Because the gradient of velocity time graph is acceleration. And when acceleration is 0, you reach a velocity named as terminal velocity. Perfect. Now, how to use this velocity time graph to draw the displacement time graph? Very, very, very easy. What will you do? You will say that since now in the yellow region, can you realize velocity is increasing from 1 to 2, 2 to 3, 3 to 4. The velocity is increasing in the yellow region. If the velocity is increasing in the yellow region, that means the gradient of displacement time graph is increasing. The gradient of displacement time graph is equals to velocity. If velocity for the yellow half is increasing, that means the gradient of displacement time graph is increasing. You will draw an increasing curve here. For the yellow region, or for the blue region, sorry, my bad. For the blue region, can you realize that the velocity has gotten constant? If the velocity is constant, that means the gradient of displacement time graph. I have represented displacement with S. The gradient of displacement time graph is velocity. If velocity is positive and constant, the gradient will also be positive and constant. If the gradient is positive and constant, you draw an upward sloping line like this. Simple, nothing complicated. This is a perfect example of a velocity time graph of terminal velocity. Can you see that from here till here you have a decreasing curve? From 0 to 20 seconds you have a decreasing curve, and then you have a horizontal line like this. Simple. Okay. Now you had to draw the acceleration time graph here. This is an interesting question. You were given the velocity time graph for terminal velocity. You had to draw the acceleration time graph. Now, do you remember me telling you that the gradient of this region is decreasing, that means the acceleration will be decreasing. In this region the gradient is 0, that means the acceleration will be 0. So how will you draw your graph? Initially at time t is equals to 0, you will start with an acceleration of 9.81. As soon as you reach 20 seconds, I think it is 20 seconds, yeah, as soon as you reach 20 seconds your acceleration becomes 0, because your gradient of velocity time graph has become 0. And then after 20 seconds the velocity remains constant, that means the gradient is 0, acceleration will be 0. So extend this line like this, simple. Now let's further move ahead. You have to draw the force versus time graph using the velocity versus time graph. This is also a unique type of question that has started to come in recent years. You have to draw the force versus time graph using the velocity versus time graph. Just look at the board, sit back, relax, just enjoy the lecture. Can you realize in the first yellow highlighted region, in this yellow highlighted region, can you realize that the velocity is increasing and the gradient of the graph, the gradient of the velocity time graph is what? Positive and constant, because it is an upward sloping line. If the gradient of velocity time graph is positive and constant, the acceleration will also be positive and constant. Now we have studied that resultant force is equals to ma. Resultant force is directly proportional to acceleration. If acceleration is positive and constant, your resultant force will also be positive and constant. So you can draw for the first 4 seconds, you can draw the resultant force as positive and constant like this. Okay. Now let's move on to the next piece of the graph, that is this piece, blue highlighted. Here can you analyze that the gradient of this graph is 0, acceleration is 0, that means force will also be 0. So you draw a 0 force from 4 till 8 seconds like this, yeah, 4 till 8 seconds you have a force of 0, perfect. Now the last part of the graph, that is this green region. Can you realize in this green region what do you have? You have a gradient that is negative and constant. If your gradient is negative and constant, acceleration will be negative and constant. If acceleration is negative and constant, force will be negative and constant. Now here you have to realize one more thing. Although force is negative and constant, can you realize that the green line is much more steeper compared to the yellow line? The green line is much more steeper compared to the yellow line. And if you do some calculations here, the yellow line is going from 0.7 to 1.4. Oh, the yellow line is going from 0.7 to 1.4 within how many seconds? 4. So rise over run. What is the rise here? 1.4. What is the run here? 4. 1.4 divided by 4. This is equals to 0.18. However, for the green line, you are going from 1.4 to 0. Oh, sorry, my bad. This is 0.7. The rise is 0.7. Why do I say that? But a yellow line ka rise jo hai, that is 0.7. Why do I say that? Because you are initially at 0.7, you are going to 1.4, the rise is 0.7. Your answer comes out to be 0.1. Now for the green line, you have a fall of 1.4. You have a run of 4. What will the gradient come out to be? 1.4 divided by 4, that is 0.36. Can you realize that the gradient of the green line is twice in magnitude? And also it is negative. So the force will be negative and twice in magnitude. So if this was 5 boxes, this will be 10 boxes in the negative side. You can complete the graph by drawing vertical lines. Simple, nothing complicated. These are some tips for examination that you can read out. Then you have some definition of dynamics that you can also read out. These are some formulas of dynamics, easy peasy. I hope you go through them. These are also explained in this speedrun video. Now the graph for dynamics. Always remember the area under force versus time graph. That is this area. The area under force versus time graph represents what? Change in momentum, or momentum, you can say anything here. The area under force versus time graph represents momentum or the change in momentum. You have to determine the magnitude of change in momentum. What will you do? You will calculate the area under the graph. How will you do that? 1 upon 2 into the base, that is 5 milliseconds. 5 into 10 is the power of minus 3. What is this height? Sorry for that. What is this height? What is this height? What is this height? Let's calculate that. This is 200. This is 400. You are going from 200 to 400. That is 200 units in 10 boxes. One box represents how many units? One box represents 20 units. Okay. So this thing will become what? 240. Okay. So your base is 5 into 10 is the power of negative 3. Your height is 240. Can you calculate the change in momentum? Easy peasy. Always remember that the area under the force versus time graph is equals to your change in momentum. Nothing complicated here. This comes out to be 0.6 Newton second. These are the units of momentum. Okay, now we have to draw the acceleration time graph from the momentum time graph. This is also a very recent question. This is a very recent question. You have to draw the acceleration time graph using the momentum time graph. Just look at the board, sit back, relax, and enjoy the theory. Now, what will be the gradient of this graph? What will be the change in y over change in x of this graph? Change in momentum over change in t. Does this look familiar? Yes, this is equal to the resultant force. Can you calculate the gradient of the first half of the graph? Can you calculate the gradient of this line? Yep, easy peasy. So, the first line is starting from 0, 0. Here. Okay, and it is ending at this point, that is x8 and y. 1 second, let me calculate y. This is your value of y, which will be equal to, this is 1, 2, 3, 4, 5 and 7.2. This is equal to 7.2. Okay, this is equal to 7.2. Can you calculate the gradient here? Yep, easy, I think. Yeah, it should be easy. So this will become 7.2 into 10 is the power of 4 divided by 8 is equals to your resultant force. 7.2 divided by 8, okay, multiplied by 10 is the power of 4. Yep, your resultant force comes out to be 9,000 newtons is your resultant force. But you don't have to draw the graph of resultant force, you have to draw the graph of acceleration. So 9,000 is equals to mass into acceleration. What is the mass? 1800. Mass, that is 1800 into acceleration. 9,000 divided by 1800, what does the acceleration comes out to be? 5 ms minus 2. So for the first 8 seconds your acceleration will be 5 ms minus 2, somewhat like this. Okay, now let's do the same magic for the last part of the graph. Okay, let's see here. How can we calculate the gradient? Here you have 1 point. The second point will be x12 y0. So the second point is x12 y0. Can you calculate the gradient here? Yep, 8 7.2 x12 y0. Okay, so y2 minus y1 0 minus 7.2 x2 minus x1 12 minus 8. Perfect. Negative 7.2 divided by 4. Okay, this comes out to be negative. Also, can you realize on the y-axis we have a power of 10 is the power of 4? You have to multiply that as well. Okay. So you have a 1.8 into 10 is the power of 4 resultant force. Okay, so what will your acceleration come out to be? Very easy. Mass is 1800 into acceleration is equal to negative 1.8 into 10 is the power of 4. So negative 1.8 into 10 is the power of 4 divided by 1800. Acceleration comes out to be negative 10 ms minus 2. So yeah, for the last 4 seconds you will have an acceleration of negative 10 like this. Join them with a vertical line. Yeah, joining them with a vertical line is necessary to maintain continuity of the graph. Okay, now this graph is also important. This is also a repeated graph. Okay, let's see what is happening here. Let's read out this question. A block is pulled in a straight line along a rough horizontal surface. So if you have a rough horizontal surface, that means you have a frictional force. As shown, air resistance is negligible. Assume that the frictional force, see, This is what I was saying. If you have a rough surface, you will for sure have a frictional force exerted on the body by the surface and has a constant magnitude of 2 Newton. Okay, so a frictional force is always acting on the back that has a magnitude of 2 Newton. The variation with time t of the momentum of the block is shown in figure 3.2. Okay, you have to sketch a graph to show the variation of force x from time t is equals to 0 till time t is equals to 6 seconds. Now realize one thing, beta. Realize one thing. The gradient of this graph, that is change in momentum over change in t, gives you what? Resultant force. This change in momentum over change in t gives you the resultant force. Okay, not some normal force but the resultant force. So let's calculate the gradient for the first half. The momentum change is 6, the time change is 4. The resultant force comes out to be 1.5 Newton. But you don't have to draw the graph of resultant force. You have to draw the graph of force x. You have to draw the graph of force x. What will be force x? If the resultant force is 1.5 Newton, and how will you write the resultant force? X minus 2 is equals to 1.5. X will be equal to 3.5 Newton. So that basically means that for the first 4 seconds, your resultant force will be 3.5. So you draw a horizontal line like this for the first 4 seconds. Simple, nothing complicated. Okay. Now for the last 2 seconds, can you realize here the gradient is, or change in p over change in t is 0. That means resultant force is 0. If the resultant force is 0, that means what? Forward force equals to the backward force. That means x equals to 2 Newton if the resultant force is 0. So from 4 to 6, your x will be equal to 2 Newton like this. Connect the lines vertically to give your continuity in graph. Simple. This should be your answer. Let's further move ahead. To the next question. This is a similar question. Okay, this is a similar question. You can try very easy. These are some tips for the examinations that I have noted down from the last 20 years of past papers. Now these are some definition for forces. Please try to memorize it, and also remember that the pressure in solids is given by this formula, pressure in liquid is given by this formula. There are two formulas for upthrust: rho g, volume of the object, and change in pressure into area is also your formula of upthrust. These are some more formulas for the chapter that you need to remember. Okay, now let's draw the graph of work done versus time. How will we draw the graph of work done versus time? Sit back, relax, you don't need to panic. Okay, what is the formula of work done? Work done is equals to force into time. Perfect. At time t is equals to 0, your velocity is 0. This was given in the question. Perfect. At time t is equals to 0, your velocity was 0. Now, you have to calculate the graph of force versus time. How are you? Sorry. Work done is equals to what? Force into distance. Sorry, my bad. At time t is equals to 0, your initial velocity was 0. You have to calculate a graph of force versus work done versus time. Very easy if you just focus on the board. If you just focus on the board for a minute, this will get easy. Now, if you are initially starting from 0 and then accelerating, how can you calculate this distance d? You can utilize this equation of motion. S is equals to ut plus half at square. This entire thing becomes 0. The distance s is equals to what? Half at square. So you can plug that distance here. This s is your distance d. बेटा ये d की वैल्यू क्या आई है? Half at square. You can plug that in here. So you will write work done is equals to force into half at square. Can you further realize that force and half acceleration are constant? Force and half acceleration are constant. That means work done is directly proportional to time square. For a quadratic relationship, your graph is somewhat like this. Simple. Okay, Ji, then you have some definitions of work energy power. I suggest you memorize this. These are some formulas for work energy power. I have written them here as well. Just simple basic formulas. Not no graphs. Unfortunately, there are no fortunately or unfortunately there are no graphs in work energy power. Similarly, for elastic deformation, you have these couple of definitions, some formulas here, then some formulas again here. Okay, in elastic deformation, you do have some graphs. Let's see those graphs. One type of graph that usually comes is when elastic potential energy, or you can better phrase it like this. One graph that you usually have to draw in elastic deformation is when kinetic energy is getting converted into elastic potential energy, and you have to draw a graph of kinetic energy versus the extension x. So kinetic energy is equals to elastic potential energy, which formula of elastic potential energy will be put here, 1 upon 2 kx square. So 1 upon 2 k is what? A constant value. You will replace it with a direct proportionality sign. Kinetic energy is directly proportional to x square. You have a curve like this, simple. Now if you have to draw a graph of elastic potential energy versus extension, you will again plot it like this, because elastic potential energy is equals to half kx square, and half k is constant. Elastic potential energy will be directly proportional to x square. You will draw an upward curve like this. Now this was also an interesting question where you had to draw a graph of gravitational potential energy versus extension. Here your gravitational potential energy was getting converted into extension, and you had to draw a graph of height versus extension. So you will say gravitational potential energy is equals to elastic potential energy. Then you will say gravitational potential energy is mgh. Elastic potential energy is half k x square. Bring mg to the other side. Height is equals to 1 over, you can say, k 2 mg x square. Now can you realize k is also a constant, 2 mg is also a constant, all this fraction is a constant, h becomes directly proportional to x square. You again have an increasing curve like this. Then you have some force versus extension graphs that you need to remember. The point up till where the force versus extension graph remains linear is your limit of proportionality. After limit of proportionality, your graph usually curves towards the extension axis. Why I am saying usually? There have been some occurrences in the examination where the examiner says that your spring becomes hard to stretch after limit of proportionality. So if your spring becomes hard to stretch after limit of proportionality, it will bend towards the force wala axis. But अगर आपका spring normal है, and in 90% of the scenarios, after limit of proportionality, your spring bends towards the extension axis, it becomes easier to stretch. Simple. These are some points that you can memorize. Now for waves and superposition. Luckily for waves and superposition, you have more definitions here. There are more definitions and more formulas compared to graphs. There are less graphs for waves. Okay, so there are some graphs. Let's see them. For waves, you have two types of graph: displacement time graph and displacement distance graph. You need to remember that the maximum points on both the graphs are known as crest. The maximum points on both the graphs are known as crest. The minimum points on both the graphs are known as turfs. Here as well, here as well. And on the displacement time graph, the time taken to complete one wave is known as time period. On the displacement time graph, the time taken to complete one wave is known as time period. On the displacement distance graph, the distance traveled by one wave is known as wavelength. So these are the two things that you need to know. On a displacement distance graph, the distance taken by one wave is known as wavelength. However, on a displacement time graph, the time taken by one wavelength or one wave is known as time period. Simple. Okay, now you have some intensity graphs as well. In a Young's double slit experiment, the highest intensity is at the central bright fringe. Then you have the first dark fringe, then you have the first bright fringe. The intensity keeps on fluctuating between the bright fringe, dark fringe, bright fringe, dark fringe. However, if you don't have a Young's double slit experiment and if you just have a diffraction grating, you don't have these fluctuations, you don't have these up and down fluctuations. However, your graph is a smooth curve with intensity decreasing down. This is a point that most of the student body will ignore, and if you want to get an A star, you must remember this. Okay. Now let's also plot the graph of x versus lambda. X is equals to lambda d over A. Can you realize x is directly proportional to lambda? But you also have to be cautious that at lambda or a wavelength of 400 nanometer, there will be numerical value of x. So you will draw it with a positive y-intercept and a straight line like this. Simple. Actually, then you need to understand this graph as well. This is the typical graph of a diffraction grating. D sine theta is equals to n lambda. Sine theta is plotted on the y-axis. Sine theta is equals to nd over lambda. Sine theta is on the y-axis, n over d is your gradient, lambda is on your x-axis. Simple graph, nothing complicated. Now this is a very unusual graph and was only asked this was only asked once, I guess, in the last 8 years. This is asked only one time. So please pay attention, this can repeat, okay? So you have a beam of vertically plane polarized light that is incident normally on a polarizing filter as shown in figure 5.1. Okay. The transmission axis of the filter is initially vertical. Okay. The filter is then rotated through an angle of 360 degree while the planes of the filter remain perpendicular to the beam. Okay. On figure 5.2, sketch a graph to show the variation of intensity of light in the transmitted beam with the angle with which the transmission axis is rotated. So initially, when the transmission axis is vertical, all the vertically plane polarized light will pass through. Your intensity will be maximum. However, if you rotate this transmission axis by 90 degree, make it horizontal, none of the vertical light will pass through. Your intensity drops to 0. Again at 180 you have a maximum, 270 0, 360 you again have a maximum. So you can draw a graph like this. Simple graph, nothing complicated. Let's further move ahead. Okay, so now you have this unique sort of graph where you were given the intensity graph and you had to draw the graph of amplitude. So how will you draw that? Just focus for a bit. So this is the intensity versus distance graph. Okay, you had to draw the amplitude versus distance graph. So first thing right off the bat, you must remember one thing. Intensity is directly proportional to amplitude square and intensity is inversely proportional to 1 over d square. Perfect. You will utilize both these equations to say amplitude is inversely proportional to 1 over d square. Take under root on both sides. Amplitude is inversely proportional to 1 over d, the formula that you will use here. So initially, if your amplitude is 1, initially your intensity is 1, your amplitude will also be 1. At 4 seconds, what is your amplitude equal to? 0.06. Sir, how do you know that? Because if you realize you are going from 0 to 0.2, how many boxes are you covering? 10 boxes. One box is equals to what? 0.02. 3 boxes will be equal to 0.06. Can you realize your intensity has gone from I to 0.06 I? What will happen to amplitude? Amplitude will go from A to under root 0.06 A. Always remember, whatever happens to intensity, square root happens to amplitude. So amplitude will be 0.24 A. So you have to take 0.24 here, that is roughly here at 4 seconds. You have the second point as well. You can draw a curve sort of like this. Somewhat like this. See, inverse proportionality always has a curve. Inverse proportional relationships always have a curve. So you draw a curve somewhat like this. My drawing is pathetic. I hate my drawing. Somewhat like this, you draw a curve. Okay, then you have the graph of Doppler effect versus observed frequency. Always remember, whenever your object, your sound emitting source is moving towards the observer, whenever your sound emitting source or your vehicle is moving towards the observer, you will have a frequency maximum. which point is of frequency maximum. These points, all these orange points are the points when the vehicle is moving towards the observer. However, when the vehicle is moving away from the observer, let's say this blue point, you are moving away from the observer, you will have a frequency minimum. Now, where are these frequency minimum points? Here, here, and here. Now, a point for the A star students. At these middle points, at these middle points, at these middle points, your object is neither moving towards, neither moving away. Hence, your frequency observed at these points remain unchanged. At these points, the frequency observed remain unchanged, or you can say it remains at the equilibrium value. Okay? It remains at the equilibrium value. Now you have the graphs for stationary waves as well. A stationary wave travels in quarters. In the first quarter, this loop comes downward, this moves upwards, the waves flatten out. Then this moves further downward, this moves further upwards. The wave flips after another quarter of a time period. Then this loop starts moving upward, this loop starts moving downward, the wave again flattens out. Then this keeps moving upward, this keeps moving downward. After one quarter of a time period, again the position changes, and after a complete time period, you again arrive to the original position from where you started. You can see the position at time t is equals to 0 and time t is equals to capital T are same. Then you have some current key definitions, voltage, Kirchhoff law, second law. You have all of them. You have the formulas as well. Now this is something that has took me a while to get. This document has took like a while to compile, and अभी रात के 3 बज रहे हैं. So I hope you realize the effort. वैसे तो I don't say it, but I hope you subscribe and share the video among your friends. You also need to know the graph of non-ohmic conductors. Whenever the resistance is increasing or the voltage versus current ratio is increasing, your voltage versus current graph will be an increasing curve. Your current versus voltage graph will be a flip of that. This will be a decreasing curve. For filament lamp, this will be the case. This is the most asked questions. For filament lamp, the voltage versus current graph will be increasing. The current versus voltage graph will be decreasing. However, for a thermistor, your voltage versus current graph will be decreasing. Current versus voltage graph will be increasing. For a diode, you have a current versus voltage graph like this. This was given in the examination, so I have pasted it here as well. Okay, now if you want to draw the graph of terminal potential difference versus current, this is your graph. The gradient, do you remember the gradient of this graph is equals to negative internal resistance? All of this has been discussed in this speedrun video. I am showing you the graphs now. The y-intercept is your EMF. Y-intercept is your EMF. Simple as that. Okay. Now you also have the graph of drift velocity versus distance. You can realize at the initial point, the diameter is d, the area is a. At the final end, or at the right side of the cylinder, your diameter becomes 2d, your area will be 4a. Now you also realize drift velocity is equal to current over NAE. Drift velocity is inversely proportional to area. If area increases by 4 times, drift velocity decreases by 4 times. This is your graph for drift velocity versus the distance traveled or versus the area. Then you have particle physics, you have some definitions, and for particle physics there is one more thing that I need to reiterate here. Please make sure that you go through the last 3 pages of the particle physics notes. They are very important. They can repeat in the examination. So yeah, that's it from my side. I hope your paper goes good. It's 3 a.m. in Pakistan, so yeah, I will just be editing this and posting this. I hope you guys benefited from all the streams, and yeah, I hope your paper goes well. Take care, bachon. Allah Hafiz. The PDF is attached in the description below.